Hello and welcome back to Ganesh Institute. In today's video, we are taking up another topic from neural networking, or you can say soft computing, or MMTE007, wherein we are talking about perceptron. Okay, so what is a perceptron? Basically, it is a type of neural network which helps us, or we can say through which we can perform binary classification. So there will be an input. So input feature will be mapped to an output decision, and that too by classifying data into 0 and 1. Okay. So let's take up one question which has been repeating in the question papers for so long. Almost you can say in every question paper you will find it. So the question is, consider a 3-layer perceptron with 3 inputs and 1 output units given the initial weight matrix. So weight matrix is given for hidden and output nodes. Okay, so WH and W node is given to us, and it's saying further that if input vector is this, calculate the output. Of course, because perceptron maps the input into output decision. So input is given to us and we have to find out the output, that too using hard limiting function or step function as activation function. So see, what's given to us is a hidden matrix, which is 210122031. 210 122, just bear with me, I don't know why it's not 122 and then 031. Yeah, and then we have one output as -112. Okay, and one input function is given to us, which is 340. Yeah, okay. In order to find out one output, you need to firstly find out, because it is asking us to use activation function, right? So activation function or hard limiting function or step function, what it is? It is like if your function has its value as 1, your function will always give output as 1 if the input is given as the value greater than or equal to 0. And this function will always be equal to 0 if its value is less than 0. Okay, so this is the activation, or we can say activation or hard limiting function or step function. Okay, so this is it. Now that means we have to find out what's the value of x, for which we'll find out the value of fx, right? So how can we do that? So for that we have to calculate the hidden layer. That's the value of x. Okay, so hidden layer, how do we do the calculation? Hidden layer neuron, the formula is you need to multiply the rows of weight matrix with the input vector. Okay, so both of them are given to us. Let's do it. So firstly, in weight matrix, what is given to us? First row 210 and input is 340. So 2 times 3, 1 times 4, and third is 0 times 0. Correct? So what we are going to do, or what we are doing, we are considering this first row, first element with the first, then because this is hidden matrix, hidden weight matrix. So 2 3s are 6, 1 4s are 4, and 0 zeros are 0. Okay, so you need to simply multiply weight matrix with input 1. Okay, so it gives us what? 2 times 3 is 6 and 4 10. Okay, so this is our x. Now what will be our fx as per the activation function? So that means f10, because x is greater than or greater than 0, so its value is 1. Remember, in perceptron we have to classify the data into 0 and 1 only. Okay, binary function. So because it is greater than or equal to 0, so we are considering it as 1. Okay, so this is my first hidden layer, neuron 1. This is the neuron 1 to feed the data. Then next calculation is for second row. So hidden neuron 2, let's say hidden neuron 2. So that means second row and the input function. So second row is what? 1 2 2, and this is 3 4 0, correct? Okay, 1 times 3, 2 times 4, and 2 times 0, right? So 3 ones are 3, 4 twos are 8. It becomes what? 8 and 3 11, right? So this becomes 11, and again it is greater than or equal to 0, so we can say that for this activation function is what? F11 is again 1. And then for neuron 3, third row with input function. What's the third row? This is it, 0 3 1, and input function is 3 4 0. So while multiplying it, we can get 0 times 3, 3 times 4, and 1 times 0. This is 0, this is 0, 4 times 3, 12. Again, this is greater than or equal to 1, so activation for this is 1. Okay, so we have got the output of hidden neurons. Okay, what is it? The activation. So first activation is 1, this one. Second activation is also 1, third is also 1. So we've got output as 1 1 1, right? Now this is the output of hidden neurons. We have to calculate the output layer also. So the formula for output layer is output of hidden neurons when it gets multiplied with output neuron, you will get output layer. Okay, so let's see. So what's your output neuron? What's the output neuron given to you in the question? So we have this output matrix -1 1 and 2. Okay, so -1 1 and 2. So you have to multiply it with the output of hidden neurons, which you've got as 1 1 1 1 1 1. Add them up. So -1 plus 1 ones are 1, 2 ones are 2. You've got as 2. So activation for this becomes F2, that is again greater than 0, so answer is 1. So we can say that output for this perceptron of 3 layer is 1. This is the answer. Okay, you can make a table out of it as well if you want. So you are given with the hidden layers, 3 rows, that means 3 layers, 1 2 and 3. Input was given to you as what? Input in the question is 340, 340, right, for each and every hidden layer. Then the sum, the weighted sum is what? for first one you got it as 10, then 11, then 12. Yeah, 10 for the first one, then 11, then 12. And because all of them are greater than 0, so their activation, next column is activation. You have to make it, in this direction. So activation for all of them is 1 because they are greater than 0. And then the output of neurons, respective neurons, we got as 1. Yes, here, this one. So literally the output becomes 1, 1, 1. This is how you can solve the questions related to perceptron. If you like this video, then don't forget to like, share and subscribe my channel. Till my next video, take care of yourself. Bye bye.